So, grade 9s, we're starting off with chapter 2 this year. And 2.1 is comparing and ordering rational numbers. So, rational number, that's a definition that we need to deal with first. And it is a number written as A over B, where A and B are integers and B is not equal to 0, because you can't have 0 in the bottom of a fraction or a division symbol. It can also be described as any number that can be written as a fraction. And a couple of examples. -4 qualifies as a rational number because it can be written as -4 over 1. It's the same value, and that's a fraction form. The decimal number 3.5 is also a rational number because it can be written as 3 1/2. Or if you want it as a proper fraction or improper fraction, 7 over 2. Fractions themselves, positive or negative, like -1/2. 1 3/4, these are all rational numbers. Even the number 0 is a rational number because it can be written in fraction form, well, 0 over any kind of denominator. 7, for example, works. Now, compare and order the rational numbers, show your work. So there's a set of rational numbers here that we need to organize. So, method 1, we can use estimation. What numbers are smaller than 0? There's a couple here that are negative. So we can ask the question, is -1.2 or -7 over 8 closer to 0? If we look at this, 1.2 is greater than 1, just the number aspect of this. And 7 over 8 is less than 1 because it's a proper fraction, it's not an improper fraction. So that means -7 over 8 is closer to 0 than -1.2 is. So we can put that on a number line. Let's see. We'll stick -1.2 here, and let's just say that -1 is there, -7/8 might be there, just as approximations. So we've got those two that are put in order now, out of the negative numbers that are on this list. Now, we can look at the number 9. Well, yeah, I've already said that 7/8 is closer to 0. So 0.5 repeating, 4/5 and 7/8 are all positive, so they will be to the right of 0 on your number line. Using estimation, we know that 0.5 repeating is close to 1/2. And 7/8 is close to 1. So 7/8 is bigger than 0.5 repeating. Using estimation, the order from least to greatest is -1.2. Oh, we missed 4/5, didn't we? -7/8, 0.5 repeating, 4/5. If you turn it into a decimal, 0.8. And if you turn 7/8 into a decimal, it's 0.875. So it's going to be the next number in line. So 4/5 is actually next, and then 7/8. So smallest, most negative, smallest positive, and then getting larger here towards the right. And we can sort of put those on the number line here as well. We can put 0.5 repeating somewhere over there. 4/5, and then 7/8. That's pretty rough. All right, method number 2, instead of using estimation, we can use decimals. So an easy way to compare numbers is to use them in decimal form. We can write all the numbers in the same form, and then by changing the fractions into decimal numbers. So let's do that. Oh, there's a formatting issue going on here. So -1.2 is already in decimal form, so that one's done. 4/5, just divide. 4 divided by 5 is equal to 0.8. 7 divided by 8 is equal to 0.875. 0.5 repeating, well, we can just rewrite it this way for now. And then I'm going to put this over here. So -7/8, well, it's just a negative version of 7/8, right? So it's -0.875. So now these get to be a lot easier to put on your number line. If this is -1 here, -1.1, -1.2 goes here. The other negative that we have was -0.875. So this is -0.9. So this one here is going to be -0.875. And then we've got 0 here. right here, this is 0.5. This is going to be 0.5 repeating. Then we've got 0.8 right here. And then this one here is 0.875. So that's the numbers on your number line using decimal form. It might not be a bad idea to also write the equivalents in the form that they were provided initially. Negative 1.2 is already given as that. Negative 0.875 was actually given as negative 7/8. So I'm going to also write that here, negative 7/8. This was given as in this form already. You could have written it as 0.555 ... if you wanted. 0.8 was actually given as 4/5. And then this one was 7/8. So it's not a bad idea to double label these. Then when you're writing the list out using the numbers as they were originally presented, you're less likely to mix them up. So smallest number is where we're starting, going from least to greatest. This is ascending order. So we're going to start on the left and move to the right. So first number up, negative 1.2. It's already there. Next one, we're going to use the negative 7/8 version of it. So that's what's up next. Moving to the right, 0.5 repeating. Then we're going to use the fraction form of 0.8, which was 4/5. And then the fraction form of 0.875, which was 7/8. So that's the order in ascending order. We're also going to write them here in descending order, which is largest to smallest. And so that's the opposite for this list. So we're going to start here, 7/8, 4/5, 0.5 repeating, negative 7/8, and negative 1.2. Now, because we wrote them in ascending order already, we can just work from it. Or you can go back to your number line, start on the right-hand side, and work your way to the left. That works for descending order as well. Next up, we've got a show you know. Please go ahead and give that a try.